So let's not start. Now, last meeting, uh, I have shown, we have tried to create a version of the IAS program, no, for the fourth factorial. The fourth factorial, which uses a loop. Do you follow? No? So I've been working on that. No? Ito. Now, what basically we will do, what we basically do is to convert our, to convert our program in the analytical engine, which is the factorial program. Now, can I show you that anyway? No, fourth factorial. Okay. Do we have a looping equivalent? Okay, we don't have a looping equivalent, but anyway, we will adapt the same process, no, for the averaging program. Okay, do you follow? Do you follow? Okay, the averaging program. Now we will have a problem. Why is that? Because, okay, the logic in any language will be the same, right? The logic of a program or any logic for that matter will be the same in any language. Now we have very similar instruction sets. Let's look at that. No? The instruction set of if there's a load, okay, in the IAS, there's also an L, right? In the analytical engine. Now, if there's a times in the analytical engine, there's also a mul, no, in the IAS. If there's an S command in the IAS, there's also a store command, or a S command in the analytical engine. There's also a store. If there's a minus, there's a sub, no. And now there's a CB, right? There's a CB program, which is almost equivalent to the jump plus of the IAS. Let's look at the documentation anyway, no? Okay. Okay. The documentation of the CF and the CB. And the IAS instruction set. You can open them both, no? So we have a CB. I hope you can see that. Let's look at the documentation of the CB. Here it is, no? CB11, it goes back 11 steps, no? Okay, which means set, no? 1 minus 4 will set the lever. Okay, which means it goes back 11 times, 11 steps. 1 minus 3 will also set. 1 minus 2 will set the lever, and 1 minus 1 will not set the lever. So it will proceed to the next. No? Okay, do you follow? Now, for the we have jump plus, which means that if the accumulator register is a non-negative, it will jump. Okay, so they're almost equivalent because we know that 1 minus 4, that's a negative 3. 1 minus 3 is a negative 2. So which means that if it's negative, okay, if it's a negative, it will proceed. So which means it will access when it's not negative also, no? So CB is like jump if not negative. Do you follow? Okay, jump if not negative. That's the equivalent of CB. In fact, there are programs, there are machines that support, no, commands jump if not negative. The IBM PC works for that, no. For example, if you have the instruction set, no. If you look at the instruction set of the Intel 88, no? This is the same instruction set used in the conditional jumps. The modern Core i7 or Core i computers, no? Core i CPUs. There's a lot of jumps, no? Okay. There are the jumps. These are the jumps, no? Okay. You'll have J and Z. Jump if not 0. Okay. So jump if not negative. That's this J and C is if it's either positive or negative as long it's not a 0. There's also jump JG. Jump if greater than. Okay. Or jump if not lesser than or equal. Greater than is not lesser than or equal. Jump if above 0. Okay. It means it's positive but it's not 0. So there's a lot of jumps, no? So nowadays, the modern computers will have a lot of jumps for easier programming. Now, if you look at the two computers we have studied so far, CB and Jump Plus are almost the same, but there's a subtle difference. That's why it's very hard to write programs, okay? Or even just translate programs from one machine to another. Okay, do you follow? I will show you that. No? So for example, here's the okay, the simple program, no, for the factorial program, this time for the IAS. We will use the same logic. No? The first part of the logic will be to compute the partial product. The second part will be to compute the next multiplier. Right? Do you follow? So this is our next multiplier here is 4. No? It's here. And then our partial product is initially 1. Okay. And dito ito 1. No? Sorry. Our partial product is initially 4. No, our decrement is 1. Do you follow? Okay. And then we have a jump 6009 because we are going to jump to the left of 6. Okay. I hope you have no problem with distinguishing the left and the right anymore. No. 0 to 19 is left. 20 to 39 is right. Do you follow? Because horizontal addressing of the present in the IAS. No? Okay, the first is let's trace this. No, this is the same logic that I have converted. Okay, myself. So the jump plus here is the equivalent of the CB. The main difference is in a jump, the operand is an address. In a CB, the operand is the number of steps to move backward. Do you follow? Okay. Any questions so far? Okay, do you follow? So this is like CB11. But this time we are going to jump to 6L because this is the beginning of our loop. Right? All right. So this is, so we have AC receives M1. So that AC receives 4, which is our initial product. The first computation is compute for the first partial product. Mul M3. M3 is 1. So the content is of the processor is 4 times 1. AC receives 4. Do you follow? And then we have store M1. So our first partial product is 4. And we load M3 because the next step is to compute for the next multiplier. Sub M2. So we have 4 minus 1 because M2 is a 1. Do you follow? So AC becomes 3 at this point. Okay? Do you follow? So this is the logic. First, compute the partial product. Then compute for the next multiplier. We store the next multiplier, which is 3. Okay? So the accumulator is 3 at this point. And then we say jump plus 60 to 19. So what will we do? Will we jump or will we proceed to 9R? 9R, remember, is a halt. Jump plus means if the accumulator is a plus, okay, is a plus, 0 is a plus, by the way, we will go to 6L. So which means we will have a second pass. Do you follow? Second pass tayo, balik tayo dito. We are going back here at 6L. We are going to move to go back to 6L because our accumulator is positive. So what's the first step? Compute the partial product. The current partial product, which is M1, is 4. We mul M3. M3 is now 3 because we have deducted it by 1. So 4 times 3 is times 3 equals 12. And we store the partial product, which is 12. We have stored the partial product. What's the second step? Compute the next multiplier. The current multiplier is 3. So we load it to the accumulator on M3. Okay, and then we subtract 1. So the accumulator becomes 2, and we store it as our next multiplier, which is 2. And then we jump plus again, since this is a plus, 2 is a plus, right? So we go into a third pass. Okay. So we go into a third pass. So we load 12, which is the partial product. We multiply it with the next multiplier, which is 2. So we'll have 24, and we save the next partial product, which is 24. Now we compute for the next multiplier. So we load 2, we subtract 1, we get 1. And that's our next multiplier. Okay. Do you follow? Now, the next is jump plus. 1 is still a plus. So we'll proceed. So we will go here. Okay. And then we compute the next partial product. 24 being the last one, we multiply it with the next multiplier, which is 1. So 24 minus times 1 is 24. We store it here. We compute for the next multiplier. We have 1. Okay. 1 minus 1 equals 0. Now, jump plus will only jump if the next value is non-negative. Okay. Jump if not negative, which means that it will jump if the value is 0 or upwards. Because okay, 0 is included as positive because jump plus is jump if the value is not negative. It's not jump if positive, no? The next instruction, here it is. Now, if the number in the accumulator is non-negative, okay, jump to the left of the specified instruction. Okay, if the number of the jump to the right. So if you look at this, no, if you look at our there's the issue here. Okay. Nandito yung issue ngayon. There's the issue here. Okay. 1 minus 1 is a 0. So therefore, it will jump again. Okay. Do you follow? We'll go back. So we load the next, there's the mistake. We load the next partial product. Okay. And then the next multiplier is now a 0. So 24 is 0. Do you follow? Our next partial product is 0. And we subtract 1. Now this time it will proceed to a halt because it will jump, okay, if it's not negative, no? Okay, if it's now a negative, so it will proceed to 9R, which is a halt. It's true, we have the last accumulator, which is -1, which causes the jump, but our last answer is 0. Do you follow? Do you follow? Okay. Okay. So anyway, let Tadayuki celebrate his birthday. We are just going to save this. Any questions so far? So there is the main issue here. Because although CF and rather CB and jump plus are almost the same, they differ in 1 minus 1. Because 1 minus 1 for the IAS will not set. Okay, let's read this. No? But 1 minus 1 rather will set, no? 1 minus 1 for the IAS will still set, but 1 minus 1 for the analytical engine will not set. Do you follow? They are not exactly the same. They are the same for 1 minus 4, 1 minus 3, 1 minus 2, but they are not the same for 1 minus 1. And no matter what, we cannot convert, no? We cannot convert our analytical engine program because we only have a very limited jump command. Okay, very limited. Unlike nowadays, we have a lot of jump commands. So we can convert this because most probably there's an exact equivalent, no, for the jump, the CB of the IA of the analytical engine. Do you follow? So there's the main problem there. Okay. So by the way, the assignment is moved to August 9. Okay, so that we will discuss the approach here and you will apply that to your assignment, and we will discuss the assignment by the next meeting after August 9. Okay. I think August 9 is our next meeting. Is that correct? Yes, August 9 is our next meeting. So we'll discuss the assignment here. So what's the problem? We don't have a command which is the direct equivalent of CB. Count backwards. But can we program this? Yes. No. You can program this. Before I introduce the solution, no, I'll have to. You're taking up intro to programming this semester, right? Introduction to programming, everyone.
Yes,
Everyone.
sir.
Okay, so no problem. So have you taken up loops already? Not yet, but you know assignment statements, I presume. Okay. Have you discussed looping? You can download this, no? So we will understand how to create the program. Yes, I will unsubmit everyone, no? I will unsubmit everyone today so that you can, somebody is asking if he can submit again. Yes, I will unsubmit everyone. Okay. So I'd like you to download this. Okay, because this is useful. This is very difficult to explain, no, without the necessary concept. So I have to show this to you briefly, no. Looping concepts, no. How do we create loops? Okay. Slideshow begin. Okay. Looping concepts. When you're writing programs, ang sa July 28, di ko pa na-upload, no. I'm going to upload because we had problems last time, no. I'm going to upload them together today, no. Okay, but now you understand. I hope you understand that our difficulty with loop programming was due to the incompatibility between CB and Jump Plus. Okay, Mr. Yap, no, I think this meeting is more sufficient. But anyway, I'll upload it. No, okay. Any other questions? So all assignments will be unsubmitted, and then okay. Looping concepts. Why do we need to understand looping concepts? Because we cannot create the program, okay, needed by the IAS, the assignment in short. No, there's no way to do that. You will be desperate if you will force program looping with fourth factorial using CB because there's no CB, okay, in IAS. Do you understand my point, everyone? Okay, our main problem is there's no equivalent of CB in the IAS. Jump Plus, it's not compatible. Do you follow? Jump Plus is not compatible with CB. What is a loop in programming? When you're writing a program, you may have to do repetition. No? A loop is a sequence of instructions that is continually repeated until a condition is reached. Okay? It is also called a repetition. Okay? And there sometimes we call repetition controls structures. We call them repetition control structures. These are programming language commands that define how loops are organized, how loops are created. No? So when you create a loop, you will have the head of a loop. Okay, it's the first command that is repeated within a loop. The tail is the last command that is repeated within a loop. Any questions so far? Okay, you can download the slide. No, do you follow? For example,
Yes, sir.
this is our this is our analytical engine program for computation of nth factorial. No, this is a portion. No, there's the head. No, minus is the first command that is executed. The last command that is executed is CB11, which returns the execution back to the head. Do you follow? So there's a head and a tail. The body is repeated every time the condition at the tail succeeds. Do you follow? Any questions so far? No? Okay, no? I hope it's okay. Okay. So every loop will have a head and a tail. Okay. The head is the first command executed and repeated. Okay. And the tail is the last command. Now, looping structures. What are the different structures of loops? Usually there are two structures, no? Repetition control structures. There's a bottom-up structure. What is a bottom-up structure? A structure where repetition goes from bottom, galing sa tail, okay? From the bottom to the head, based on a condition. The loop terminates when the condition is not repeated. For example, no? The factorial program we have for the analytical engine is a bottom-up loop. Why? Because during the first pass, we'll just go from head to bottom. Okay? From top to bottom. From head to the tail. When we reach the tail, we evaluate CB11. If it's not set, we go back to 11 steps. We go back to the head. So the first pass is the ordinary pass. And the next pass is a repetition pass. Okay? This will continue to repeat. This will go back to the head when the condition is not reached. Or rather is reached. Do you follow? This will continue the repetition if the condition is satisfied. This is a bottom up. Why? Because whether we are going to repeat or not depends on the bottom. Okay? Bottom up. It goes from bottom to up. Any questions so far?
None po, sir.
Okay, so galing sa baba, papunta sa taas. From the bottom to top. No? That's a bottom up loop. The example we have is a top bottom up loop. Of course, if there's a bottom up, there's also a top down loop. Do you follow? What's the difference between a top down loop and a bottom up loop? In a top down loop, the condition is in the head. Do you follow? Now, depending on if the condition is reached, it will terminate the loop and proceed to the portion after the tail. Do you follow? Do you follow? If the condition in the head is reached, it will terminate. This is called the termination pass. It will skip the body of the loop and proceed to the part which is after the tail, which means it will completely skip the body of the loop. Do you follow? If the condition is not reached, then the body of the loop is executed. And then at the bottom, no, repetition is done without a condition. So when we reach the tail, this is the tail, jump 50 to 19. There's no condition here. It will just go on to repeat at the head of the loop, which is store M3. Do you follow? After store M3, a condition is checked. If it is reached, it will terminate. If not, it will repeat. Do you follow? Do you understand? This is a top-down loop. The condition is at the top. It's like a while condition followed by a body. Now, in other languages, there's a repeat until loop, which is a bottom-up loop. Do you follow? One of the main differences between a top-down loop and a bottom-up loop is in a bottom-up structure, there's always a first pass. No, there's always one repetition. Do you follow? In a top-down loop, there may be no repetition at all. Do you follow? The body of the loop may not be repeated. Any questions so far? I hope you understand this, no? We will have an example. Okay. Types of loop conditions, no? A condition for termination will terminate the loop when the condition is reached. Like for example, it's usually used in a top-down loop. In a top-down loop, we have a condition for termination at the top. If it's reached, we will terminate the loop. A condition for continuation or condition for repetition repeats the loop if the condition is reached. Do you follow? No? There are other elements such as loop counters, no, used to count the number of times the loop is repeated. No? There's a loop counter is being incremented or decremented by a particular value every time during each repetition. Okay? Any questions so far? Now, what's the problem with our previous program? This one. This is a bottom-up loop, right? Because we will do a jump plus at the bottom, and we know that this doesn't work, which means the bottom-up logic will not work. Do you follow? No matter what you do, the bottom-up logic will not work, and it will never work because we don't have the right command. So if you don't, we can't force the issue. In other words, if you can't do it bottom-up, even no matter what we do, it doesn't work. What will we do? We use the second option, which is top-down. It's trial by error. If it doesn't work with top-down, try bottom-up. Do you follow? Do you follow? So let me rename this. This is the bottom up. It doesn't work, no? We have a second version which is top down. We'll find out if it works, okay? Do you follow? Okay, so this will be our last topic today, no? It might be short, but it's very crucial, no? This will help you solve the assignment. Without this, you can never solve. There's something that you cannot Google, by the way. It's not in Google. Do you follow? Let's put this side by side with our this is our instruction set. This is our program. Do you follow? Let me transfer the others so that we don't get. Close na natin ito. You can download the slide, no? The slide applies in any language, no? The looping concepts applies in any language. Regardless of what language, looping concepts apply are the same. Okay. So ito. Do you follow? So this is a top-down loop. So anyway, M1 will be our partial product. Let's move it here. This is 4. This is 1, okay? What will happen to our temporary lang ito, no? M3 will be a temporary variable which is used to store the next multiplier. Do you follow? I think, no? Yeah. M3 is the next multiplier, no? Yes. Next multiplier. Yes, that's correct. No? So our first partial product is 4. Our increment is 1. Okay. Now the strange thing about this is we will count incrementally from a negative value. Okay. First, we load negative of M1. Now, is this valid? Kasi it's because we are looping opposite ways, no? Negatively. Nothing will stop us from looping 1 to 3 or 3 to 1, right? It's the same looping. Okay. What is load? Absolute negative of absolute 1. We have here negative of absolute. This is the 1, 2, 3, 4, 5, 6, 7th instruction. Okay. We will convert the value to negative and store it to the accumulator. Do you follow? Do you follow? That's why there's such an instruction. Wala ito this is not in the analytical engine. Okay? This is supplied by John von Neumann to, to satisfy certain requirements, certain programming requirements. Without this, we will not be able to program the loop. Do you follow? Do you follow? If you ask, is this present in the IBM PC? Yes. No? This is present. No? Because the IBM PC already has 256 instructions. This only has 22 instructions. No? The IAS only contains 22 instructions. 10 times yung IBM PC. Okay? -4. So it's -4, right? And then we add M2. M2 is 1, so we have -3. We store M3. So M3 now is -3, which is our next multiplier. There's no problem because we can convert into absolute value. And then we jump plus to the end. This is a condition for termination. Jump if positive. Will we jump if is the value positive? Anyone? What's the value of the accumulator? Anyone? What's the value of our accumulator? AC? It's -3. So jump if positive. Is this positive? Oh, tama si Yap. You can chat me anyway. No, Yap to answered -3. That's correct. Is -3 positive? No. So this for example, so in short, this is a condition for termination. If it's positive, we will go to 9, 0 to 19. 9, 0 to 19 is this 9L. This is a halt. Sorry, this is the halt. Do you follow? This is pass number 2. This is pass number 1 here. Do you follow? So if it's a plus, we will halt. But since it's not a plus, we'll just proceed. So now you should be able to distinguish this as the condition for termination. Do you follow? This is a condition for termination. So this is a different usage, no, from the CB, because CB is used as condition for repetition. Do you follow? Condition for repetition repeats the loop. Condition for termination terminates the loop. Okay? Any questions so far? So jump plus is a -3. We'll proceed. Load M3. This is absolute of M3. Do we have this? Yes. Load ito. Load absolute. So we have load absolute of M3, which means M3 is now -3. The absolute value is 3. And then we mul M1. Okay. What is our M1? M1 is 4, no? So we have 3 times 4 equals 12. And we store M1. Our next partial product is 12. Do you follow? 12. Okay. Any questions? We have computed the partial product. The next thing to do is compute for the next multiplier. Okay. The next multiplier is in M3. We load M3. That's -3. And we add M1. -3 plus 1 is -2. Do you follow? Do you follow? Do you follow? -2. Now we don't have a condition. We just jump back. Okay? We just jump back to 5L. Going here. There's no condition. We are going to force jump back to the head of the loop. Do you follow? Take note, there's no condition anymore. We just go back to the top, which is store M3. Okay. Store M3. So the value of the accumulator is 2. So now this will become 2. The accumulator will now, rather the next multiplier becomes 2. Because remember, the previous multiplier is 3. It's 3. Okay. Do you follow, everyone?
Yes, sir.
So our accumulator is currently -2. Jump plus 9 to 9, which means, are we going to terminate? No, because the current accumulator is negative. So baligtad tayo ngayon. We are not looking at negative values. In the analytical engine, we are looking for positive values. Okay. So we are going to proceed. Load absolute of M3, so it becomes 2. Mul with M1. M1 is 12, so this is 24. So, and then we store M1. So which means that our next partial product is 24. Do you follow? Do you follow? And then we have computed the next partial product. So what's the next step? Compute for the next multiplier. The current multiplier is -2. So we load -2. AC becomes -2. We add M1 is -1. And then the next is jump back to the head. Do you follow? No conditions. Jump back to the head. So we go back to pass number 3. It's now pass number 3. Okay. Any questions? So remember the values. This is -1. This is 24. This is -2. But we store Okay, we store M3, which means whatever in the accumulator is, it's -1. We overwrite M3. So this becomes -1. Okay? -1, okay? Ano, -2 dito, and then store M3 makes it -1. So, are we going to jump? Are we going to jump, everyone? We only jump if it's a positive or 0, but this is negative. So therefore, we don't jump. We load M3. which is the absolute value, the absolute value of 1. We multiply with M1, which is 24. So 1 times 24 is 24. We have computed the next partial product. So next step is compute the next multiplier. So we load M3 negative 1. Negative 1 plus 1 is 0. Do you follow? Let me. Okay. Jump plus. If it's not negative, okay? So it's now a 0. Anyway, we are going to force jump. Force jump tayo. We have a pass number 4. Okay. Okay. Do you follow? Pass number 4 tayo. There's no question because we really have to jump. And then we reach number 4, we store M3. So, dapat dito ito. We store M3. So, 0 is now stored to M3. Jump plus. Now, what do we mean by jump plus? Check if it's not negative. Now, we will jump. It's time to jump. Jump to the edge of the cliff. No? We are going to jump to the edge of the tail. Okay? Do you follow? So, where we'll go? We'll go to 9L, which is halt. Do you follow? So now it works. We have the final answer, which is 24. Do you follow? Any questions so far? So we have solved the problem using a different logic. Okay? So there's no, I'll upload this. Do you follow? So i-upload ko na ngayon, no? So you can have this as reference. Okay. Upload ko dito, no? Sa baba. And I'll upload the session for today right away, no? What's the advantage of having this loop again? We change the value, it computes the factorial of a different number. Okay. Good thing we can edit Dagler at this point. Sometimes at this point, no, times like this, no, Dagler is usually very slow. I'll bring it there and I'll put this beside our session for today. No? Next program is a program, PDP1 tayo next time. The main difference between PDP1 and IAS is wala nang jump left. There's no more jump left and jump right. Okay, so yeah, we have a much easier computer to program. Okay. Okay, do you follow? So it's below the looping concepts. Okay. And to understand, you have to go through this in order to understand this concept. No? me open that again. Okay. So I will not make matters worse. No. Anyway, we'll dismiss early today. Okay. So there are two versions in the program. There are two versions. No? Version 1, bottom up, and the second version is top down. And we see that it works. Okay, do you follow? So
Yes, sir.
this concept is very important. No, if you are doing C++ nowadays, presently doing C++, or what are you doing, Java or JavaScript, this will still work. How to make loops. Okay, top down, bottom up, and then conditions for continuation and conditions for repetition. Very important looping concepts. Okay, did I miss anyone? So anyway, for those who are frequently absent, no, and you who have missed a lot, no.
Naka-mute po kayo, sir.
Can you hear me now? I'm sorry, I got cut off, no. I had connection problems, but anyway, I've finished the, no.
Yes, sir.
Okay, sorry, naputol sandali, but anyway, Zoom will just cut and proceed. Okay, I've noticed that Zoom just continued. Okay, so our meeting will not be cut off in the recording. Okay, during the recording there will be no cut off. Anyway, the last thing that I'd like to check is if I missed anyone. Kasi ano, Awing. Okay. Kanakan. Participants, let's check. There's still many of you here. Placer, I'm not seeing Placer ever since. Labrador. Okay, I'll upload the meetings on July 28 today, no? Right after our session. Is there Wabina and Yap? Can you just chat me?
Present, sir.
Sino yan? Si Yap ba? Yes. Okay. Okay. So we'll stop until this point, no? Anyway, I'll try to check what's wrong with my internet. Okay. So I have uploaded anyway. I have uploaded the, oh, sorry. Let me check if I have the, no? I think I have the, no? I have the worksheet fully uploaded successfully, no? It's there. Do you follow? Okay. We'll not have a new topic, so your assignment will be to continue, no? The IAS programs, the same assignment, and it's due next week on August 9. Okay, you have everything you need. Okay, you have everything you need. You can, of course, you know now that you will use the top-down loop version, no, of for the average and the sum. Okay, claro, it's clear, I think, no, because you cannot just easily convert the program from the analytical engine. Okay, our next meeting is August 9. Okay, formally, everyone. Now, for those who want to attend the makeup class, please look up for our schedule. Nandito sa taas, no? Sa announcement.
Yes,
It's in the announcement. Okay. It's here, no? August 4, 1:30 to 3. August 5, 9 to 10:50. And then Thursday, 1:30 to 3 p.m. And August 6, we have 8 to 10 and 10 to 12. August 6 is a Friday. Okay. So those who have missed a lot of meetings are welcome to attend. Okay. so that by next week we will have normal classes. Okay. So thank you everyone. No, thanks for coming.
Thank you,
sir.
sir.
Okay.
Thank you, sir.
Thanks.
Thank you,
Thank you,
sir.
sir.
Your next meeting August 9. Okay.
Yes po, sir.